both. And notice you got to have that colon there. Anytime you have a block of statements that's indented after it, you have to have that. But this keeps numbering, this keeps, if you go through the logic of this if elif, it'll keep narrowing the range till you get closer and closer, and finally you get the number. Okay. Now here's this isn't code per se, but if you're writing a program, this is a handy technique to get some sensibility, to organize your program. What this does, it just shows the flow of control, where main is the first thing that fires, and main in turn will call various functions that are defined elsewhere. And notice in this one, we're noting that 2 Celsius and 2 Fahrenheit are called by convert temp, but actually these functions are not defined in convert temperatures. These functions are actually imported from the temperature module, but we stick them on there on the hierarchy chart anyway. It's just a visual affirmation of the order of control, the order that the functions fire. And it's something you do before, and once you write the program, then you throw this away. Or you can do it like this, which is the same thing. It's just indented. Okay, so this is for guess the number game. We saw that one, and there were only 3 functions in there. There was main, which called display title first, and generally it's top to bottom, left to right. So because display menu was called first by main, we put that over here on the left. And then convert temp gets called, we put that here on the right in this first tier or second tier. Okay. So again, and these are just help you plan the modules in your program. And this slide just basically says what I just said. Okay. So let's look at one more. And I was kind of trying to hurry up because I didn't think we would get through everything, but now it looks like we will. So I can slow down. This is a kind of a silly game, an interesting game. Let's look at the rules. We have this in a program. It's called the pig dice game. So what you're trying to do here is you keep rolling. You can roll the die or you can hold. And whatever value turns up on the die gets added to your tallied score. And the idea is to get to 20 the first person who reaches 20 wins. Okay, but if you get a 1, you lose your turn. You lose, no, let's see. Turn ends when the player rolls a 1 or 2. Yeah. If you hold, the next player gets to go. If you get a 1, 1 is very bad. If you get a 1, you're out and you lose all the points to boot. If you hold, you don't lose your points. You can hold at any time that you want. Okay. So holding, just simply you pass the die to the next person and then they get to roll. Well, let's think about this. Okay. So pig dice, you're rolling a dice. So it says player enters an invalid character. The rolled or hold prompt is displayed. Okay. So this is just a data validation. You want to get 20 points. Well, what numbers are on a die? And you don't want to get a 1. So the operative number, the numbers that you want are 2, 3, 4, 5, and 6, and preferably 5s and 6s. But how long can you keep your streak going before it's likely that you'll get a 1? Okay, so this is a little more intricate program. Let's take a look at it. It's called Pig Dice. And you can see, right, it's longer. It imports random. Here's the hierarchy chart. This also reflects the greater complexity. And it's kind of lopsided in that, well, this is just display, and then everything else comes off of play game. What does that mean? Well, let's go back here and look. Right. Take turn. Go down here. Okay. In this case, main is on top. You don't have to have main at the bottom. It usually is placed in the bottom just because. This, as far as I know, this is always placed at the bottom. I guess it doesn't have to be either. But this little magic piece of code calls main, and main is real simple. Main just simply calls display rules, which prints all the rules, and then play game. And play game in turn calls game over. This is no, it's not. Calls take turn. And where's roll die? Take turn calls roll die, right? Yeah, play game calls take turn calls roll die and hold. Okay, so how does this work? Okay, well, let's do it. Okay, so it's gonna, this is a interesting little program, and first of all, it tells the user what's going on, right? And you got to assume the user knows nothing about what the program does. So you want to tell the user how to use it. Okay, so let's play pig. See how many turns it takes you to get a 20. Turn ends when you either manually say I hold or you roll a 1. And 1 is much worse because you lose your turn and all the points. Okay, if you hold, you lose your turn, but you save all the points. Okay, well, if you think about it, right? Let's say that randomly you were lucky and you didn't get a 1, but you got a 2, a 3, a 4. What's that? That's 9. A 5, that's 14. And then a 6. If you're real lucky and you don't get any 1s, if you're real lucky, and it's a random, a uniform distribution, you might make it to 20 on one turn, but that's not likely. If I can't do it in my head, but if you could figure out, you could do it intuitively. So let's try it. Okay, so roll or hold. I want to roll. And I got a 1. Okay, so I lose my turn and the next person goes. So this is the next person. And this person rolls. And he's up to 3. And I'll say, yeah, I'll do it again. Now, in looking at this, of course, it's equally likely. The fact that you got a 1 before has no bearing on your chances of getting another 1. You might think it does. You might say, well, I got 2 1s in a row. I'm not going to get another 1. The chance, it's still a 1 out of 6 chance. It doesn't change no matter what has happened before. Now, if you get into Bayesian probability, you could argue that it does, but we're not going to go there. Okay, so we say, I'm going to go again. 6. Okay, so now I'm up to 9 and I'm feeling pretty good. Roll or hold. I'll say I want to roll. Okay, I want to get at least halfway to 20. Oh, okay, so now I'm up to 15. Gosh, you know what? I might go for broke here, right? If I get a 5 or 6, I'm there, right? So I'll say roll. Okay, so now up to, what is that? 5, 11, 17. Is that right? Yeah, I guess, no, 3, I'm sorry, 3, 9, 15, 7. So now I'm up to 17. I'm going to hold. So the next person comes up. So I've got 17 points. That's what it tells me. Next person, he wants to beat me. So he rolls, gets a 5. He's going to go again. He wants to get at least halfway there and hope that I go bust. So I'm up to 9. I'm going to try it again. I'm up to 11. That's barely halfway. But am I going to make it to 20? Probably not. Okay, so this is a judgment call here. If you were risk averse, you probably would say, I'm going to hold. I'm halfway there, and I don't want to risk losing all my points by getting a 1. So I'm going to hold. But no, you wouldn't do that. The other guy's got 17. He's going to make it for sure. So I'm going to say roll. So 9, 11, 16. Okay, roll. So that's 20, right? 9, 11, 16, that's 20. So I'm there. So I hold. Total score. Okay, well, but these are different players. Okay, so the idea is to get to 20 points, and this person did. Okay, again, it's kind of an odd program, and let's take a look at it. And we'll do this on the slides. Okay, so this is a more complicated program, or at least it's longer. So here at the top level, we have main, and then it displays the rules, and main also calls play game. Play game calls take turn, and in take turn, you can either roll or you can hold, and those are 2 other functions. Okay. So now generally, if you're doing this with a hierarchy chart, you draw out this chart, but then you're going to write the nature of this chart is going to determine what functions are called in main. So by specifying this sort of chart, you're going to say, well, main's going to have this function and main's going to have this function. Okay, so you get a skeletal template or pro forma statement of it starts to write your code for you, essentially. At least you know what functions are called where. Okay. Now, so yeah, okay. Actually, you would go back and forth between writing some of the code and looking at this and maybe rearranging it and writing some of the code and so forth. Okay, so here's the interface, and we saw this. Okay, main just calls these 2. Display just simply prints all this stuff out. There's no logic in it at all. Play game. Notice it's calling functions that have several arguments to them. Okay, so we are passing these arguments, these variable values that constantly change, right? Okay, so score is individual. Here, let me see what it says. It imports a random module. No, we said that. The play game function calls the take turn function here with these 3 arguments. And on the next slide, we'll look at take turn that calls the roll die.